Okay, good evening, everybody. We're going to make a start of the Harley-Wood talk for this evening. So the Harley-Wood talk is a part of the Astronomical Society of Australia's annual science meeting being held this week here in Adelaide. And the Harley-Wood talk is one of the public or the major public outreach part of the meeting. Before we get started, I'd just like to acknowledge the Kaurna people as the custodians of the land in which this talk is being held, and we acknowledge their elders, past, present, and future. And just a quick word about Harley-Wood, why it's called the Harley-Wood Lecture, and that's because Harley-Wood was the first president of the Astronomical Society of Australia when the society was first formed in 1966. So he was the first president for a couple of years. And so today's speaker is Professor Miroslav Filipovic from Western Sydney University. And he's the director of the Penrith Optical Observatory, but he also is, and I know this firsthand, he's a passionate, what we call multi-wavelength astronomer. He has activities in optical, gamma rays, X-rays, radio, neutrinos, exotic
multi-messenger
particles. Sorry?
Multi-messenger.
Multi-messenger, we call it. I think there's not much that he hasn't been involved in. So tonight's talk, he's going to give us a series of his discoveries that he has made, I think mostly with radio, is that right? Over the past year or so, using one of Australia's recently built radio telescopes in Western Australia. So let's please welcome Miroslav Filipovic for his Harley-Wood lecture. Thank you.
Good evening. Thanks a lot, Gavin. To start through the difficulties, let me return acknowledgement of the country. Varami, I'm coming from the Darug land, which is Western Sydney. Very proud people there as well. They have a lot of tradition in astronomy. And one of the previous lectures, Harley-Wood lectures, were talking about the Indigenous First Nation people, Aboriginal people, astronomy. And the number of these stories and these discoveries are coming from the land of the Darug people. So once again, Varami from that land. A lot of people that I would like to thank. I'm considering this as probably the greatest honor that I had so far in my 30+ year career. And the reason for that is I invite all of you to go to ASA webpage and to look the previous speakers, Harley-Wood lecture speakers. It's just absolutely fantastic. To start, first, thanks, Gavin and Sabrina. This is absolutely, once again, a fantastic opportunity to show the last couple of years of our discoveries. I would really like also to thank a lot of people, about 250 of them from various institutions, particularly my master's and PhD students, which I will be mentioning a lot tonight. Super special thanks goes to ASCAP people. They are my saviors in the past 24 months. They are absolutely fantastic, and they deserve far bigger acknowledgement that I can give here. I don't know how many of them met. You are there. Hi. Thanks very much, guys, for what you're doing for Australian astronomy, for world astronomy. And I'm sure that in the future with SKA, you're going to do even better job. Colleagues from KM3Net, HES and the CTA colleagues as well, quite a lot of things that Gavin was talking about, the multi-messenger astronomy, which is the name of the game these days. Finally, I would really like to say that this talk, which is 181 slides long, which means about 1 slide per 15 seconds, is inspired by a lot of people through my life, and starting with, of course, Carl Sagan, which I never met, of course, but the guy who actually was very dominant during my university days. Nikolai Kardashev, some of you astronomers may know Kardashev scale. He was actually, absolutely terrible, but he had a huge influence on my life and really inspired me. Sandra Faber is, again, someone which I never had a chance to meet. She's still alive. She's absolutely phenomenal. I strongly invite all of you guys to YouTube, Google her. She's giving phenomenal talks, and it's very much inspirational. Ray, Fred is here. Hi, Fred. Thank you. It's very much inspirational what you're doing in ABC in the past, how many decades? Several decades. Luke Barnes, my colleague, which I talk every single day. He's my local cosmologist. Anytime I have a problem with any idea, he will explain this to me in detail. Very inspirational. He sits here as well, of course. And of course, Gavin, numerous talks over the past couple of decades, but Gavin really shaped a lot of things that I'm going to talk tonight. The future of astronomy is here. You will see a lot of ideas that I would like to sell you tonight. One of them is very much about the future. This particular future here is the CTA, the future of the high energy. And in another way, I would really like to send a story about something new that a couple of us, we think, invented over the past few months, called the high energy astrobiology. And I will be talking about this. This picture here, it comes from the ChatGPT. So please, guys, don't blame me for that. Nevertheless, I should say upfront that I may hurt some of your feelings, and I really apologize for that upfront. I think, some of my views, particularly political views, may not be something that you're gonna like, but nevertheless, please give me a chance to explain myself why I don't like what I don't like and why I like what I like. So there are quite a lot of health warnings you will be seeing there. So before I start, I would like to ask you a few questions, and you will see in about 150 slides from now why I'm asking these questions. But the first question is, who wants to live forever? I asked this question my students on population of 500, but I would be really interested, who would like here in this room, who would like to live forever? I could guess it's a Fred. Anyone else? We have a Luke as well. Fantastic. Anyone else would like to live forever? We have a third one here. Yes. Gavin, how about you? Not sure? Maybe. Well, let me tell you statistics. Statistics is that only 20% of humans would like to live forever, which is very interesting. When I ask my students who are 18, 19-year-olds, rarely I get anyone putting up their hand. Interestingly enough, the population of the humans within this 20%, they are mainly older, senior, okay? So it's quite obvious, why we would like to live forever. Nevertheless, there is a reason why I'm putting this up. The question here is, what can we do in the cosmic time? And I'll talk about the cosmic time within our human life, which is probably less than 120 years. Now, what I would really like to try to send a very strong message is that everything that we are doing in this beautiful science, it's all about the two questions, and that's the origin of the universe, and the second question is the origin of life. I'm sure that at least at some level, any of the papers, posters, any of the talks that I've heard here, I could connect to these two questions. And this is, what is, I think, in a pyramidal structure, it's what is going to govern us. You may notice that for the first 70, 80 slides, you may see some posters from some of the movies. I'm not quite sure if you can find any relation, but we'll see about that as well. So my next question is, of course, Luke and Gavin should not answer this because they know the answer to this question. But let me ask, how many of you can find out what is this number? Anyone? Nope. Okay, a small tip, nothing to do with the James Bond 007. That's very clear about that. In about 118 slides, I'll tell you the answer for that. So, life is beautiful, and this is my main message that I want to send you. Actually, guys, at every single level, the life is beautiful. Okay? Have a look at me. I'm smiling. It's beautiful. It's absolutely fantastic. We're doing fine, right? The planet is alive. Yes, we do have problems, of course. But what I want to tell you is the left-hand side of the picture, both of these movies won a big prizes. Actually, I prefer the one. But I'm very much against the miracle. I really believe that we live or die by the laws of the physics. No miracles. I'm a scientist. I don't believe in the miracles. Okay? This is the first thing that I want to say. So I'm going to give you a little bit of a summary. You will see later on, I'll talk about problems that we have around. One of them is the volcanoes. And I really think that that's the most serious problems that we have. I think, more or less everything we can, survive, more or less, at least within our cosmic time. I'll tell you what's the cosmic time in a few seconds. Now, we do have some other problems about the future of the Earth. What kind of moral and ethical decisions we're going to make, especially with the science, being a scientist. What I really believe is that we really need to talk about the future in the way, not just, astronomy, but the generally science and the humankind should go in which directions. So, in essence, I'll be talking about astronomy a lot. About 2/3 of my talk will be astronomy. About a small part of my talk will be about the ethics, morale, politics. Yes, I'm going to talk about the politics. I'll be unashamedly talking about the politics. I'll talk about the economy. I'll talk about the environment that we live in. Of course, I'll talk about, oh boy, what we are missing here. ASCAP, KM3, NET, HES, CTA, and the Rosita. Yeah, The Dish. The Dish is absolutely a fantastic movie. If you haven't seen The Dish, guys, there is somewhere at, I think, 37 minutes and 15 seconds, you can find Miroslav playing a cricket inside of The Dish. I was a PhD student back then. It's actually, quite cute. All these things, you wouldn't recognize me because I used to have a hair back then. Nevertheless, I strongly recommend this new movie. You can expect a lot of conspiracies from me, but let me be very clear here. Conspiracy is not a word that we really like to use in science. Trump can use that, whoever else, I don't know, the politicians. So the way how I'm going to use this word, it's nothing to do with the way how the politicians are using the word conspiracy. You will hear a lot from me about, I don't know. You'll hear a lot of mysteries, a lot of questions, of course, Hollywood. I already started with the Hollywood, and I'll show you a lot of work in progress. So, From Here to Eternity, another beautiful movie if you haven't seen. Effectively, for the next 80 slides, I'm going to tell you about every single source that you see here, and they're absolutely beautiful. So these sources are all high-energy sources. If you don't mind me saying is, if you're going to book your next holiday, this is not a place where to go. None of these things, So this is not a place to go and do any holidaying there. All right, okay. So as I said, the summary of the things that I would like to send the message is that us humans, we have a technology in our hands. Now, it's a big question, our morality and our ethics, what we're going to do with that. So we are writing a story of Earth, and we need to think about ending that now. We do have a lot of problems, and that problems is very much related to astronomy that we are doing. At least I'll hope to argue about that. So the first question in the part 1 of the talk, which will be a pure astronomy and the discoveries over the past 24 months, mainly ask a bit more of CTA, HES and the KM3 net, is very much around the questions, can we thrive on the planet Earth on a cosmic time? So cosmic time is something which comes from a day one or a split of a second one in the Big Bang and all the way today. And just a quick note that 37.8 million years per cosmic day. So, I'll be talking about probably about 3 or 4 cosmic days, about 100 million years plus and minus in the next round of slides. So, alea jacta est. Let's throw that dice. Julius Caesar, 10th of January, 49 BC, crossing the river Rubicon, just north from Rome. At that point, everything has been decided. And I'm connecting that with the Big Bang. At that point, the dice has been thrown, and casted, and everything started. So there was nothing but the simplicity. Luke can tell you, he's written a number of books about symmetry, simplicity, how similar is a similar, and which directions that can all go. But what we know is, and you will hear me a lot talking about that immediately after the Big Bang, the rich gets richer and the poor gets poorer. And that's the way how we see the universe, classical textbook picture. The 5 points there, which is very important to be reminded, is that we believe that universe started when 13.77 billion years ago, Milky Way 13.61 billion years ago. As you can see, something like 150 years after the Big Bang, Milky Way has been created. Very interestingly, I found information that actually Milky Way did not change since about 10 billion years ago. So the way how the Milky Way looks now, it's been like that 10 billion years, which is quite cool. So it happened back then. Sun is about 4.6 billion years. Earth is about 4.54 billion years. And the Luca, which is the last universal common ancestor, it's probably dated about 3.5 billion years ago. These are the dates, these are the numbers. It's very important for the story that I would like to send. So this is a beautiful a story of the Eagle project. Luke Barnes, who's sitting here in the audience, and his team, and the team that he was a part of, looked into the early universe, modeling the early universe. And as you can see, it's all smooth, but with the density fluctuations of about 1 part in 1,000, which is beautiful. This is our universe. It's absolutely beautiful. Temperature, 10 to the 27 degrees. Time, 10 to the minus 35 seconds. So it all looks, fine. That's the way how it's all started. Now, this is a phenomenal picture. It's a view of the present-day cosmic web, 300 million light years across. This is, again, modeled by the TNG group. Galaxies are in gold and have blown the shock gas. It really reminds me on some indigenous paintings. It's absolutely beautiful. So that's our universe, 300 million light years across. Okay, now let me start with a conspiracy. This is a conspiracy number 1. One of the coolest galaxy clusters is a Triangulum Australis, very famous. A lot of papers has been written about that. Let me point to you a couple of objects here. This is an ASCAP image. There is an object here. As you can see, zoomed in here, and then there is an object up here. These two objects are something very rarely that you will find. Actually, I don't think it's been found anywhere else, known as a one-side jets, AGN jets. Of course, there is nothing like a one-side AGN jet. So it's most likely if you have something super resolution, you would see that the jets is on the other side. But nevertheless, have a look, connecting these two guys in the cluster, it comes to this point source. It's a beautiful conspiracy. So ready for a Star Wars. As you can see, there is a number of other beautiful AGNs and other objects. So a Triangulum Australis galaxy cluster is definitely not a place to go. I think, it's absolutely stunning. The next one is, it's one of the biggest discoveries coming from the ASCAP over the past couple of years is odd radio circles. This is one of the first one that we discover. I think this we call this number 1. Ray Norris discovered this, and at the moment we have about half a dozen. My PhD student, Peter McGregor, is about to publish about half a dozen. Barbara Korybalski also published a couple of them. This is ORC2 and ORC3. As you can see, what we think at this stage, it's most likely something to do with Phoenix Stas. I don't know, I've seen Stas. Stas is probably not here. Stas actually did a phenomenal modeling about this and found that it's quite possible that we see some Phoenix jets type of arising, there. Quite cool. This is the newest one, which is about to be published in PASA, called Anglerfish. Matt, this is the one which I'm sure that you're going to like. Again, the latest ASCAP discovery, a typical object which have most likely should be an odd radio circle. What's the odd radio circles? Basically, we don't know. It could be a lot of different things. One of the possibilities is that we should have some source of a massive galaxy in the center. The problem with this one is we have actually a well-known star. I forgot now which magnitude, but it's about 10th, 15th magnitude star. Let's say 10th magnitude star there. It looks like these stars have nothing to do with the object itself. So it's most likely that there is some sort of interactions within inside of these massive objects, galaxies, quasars. We're really not sure. But interestingly enough, they're all about the same size, angular size, about 1 or 2 arc minutes in size. Exclusively seen in the radio, which is also quite cool. And you will hear me a lot exclusively seen in the radio. The other one is, this is my Lord of the Rings. Again, it's absolutely fantastic. Have a look here on your left-hand side, the HST image. This is a classical example of 2 spiral galaxies colliding. Now, when you look these 2 galaxies colliding in the ASCAP image, which is this center here, you won't see that there, but you see a huge circles around. there. One of the possible explanation is that one of the galaxies, most likely the one here, actually somehow acquired a supermassive black hole for this guy there, and it's basically just doing a wobbling, right, processing in a line of sight, and their jets are actually, spewing chips, in our direction. So that's the Lord of the Rings. They're also huge. Oh, right. Now we have the dancing ghosts. The dancing ghosts, again, is a very interesting, it's most likely, there is not much controversy here or conspiracy there. Most likely we do have a couple of galaxies which are a part of some cluster. They have their own jets, but interesting thing is they have these wisps here, which we can't explain at all. These are the meerkat images. There are ASCAP images as well. But at this stage, we see a lot of these, but this one is particularly cool and nice ones. More of these is something which we call the recollimation shocks on some large scale. This is one of the biggest radio objects in the sky, about 43 arc minutes. It's absolutely huge. So a classical Top Gun, have a look here, the pressure mismatch between the jet and the ambient medium. So we call this a shock diamonds. And basically the same thing we are getting in this huge, enormous object as it's recollimating like these shock diamonds here. So the supermassive black hole is right here in the center, and then we have on both sides this object. Quite stunning. My ex-PhD, our ex-PhD student, Velibor, published this a couple of years ago. And then we have a trident. God knows what's this. So again, in the center is AGN, supermassive black hole. There is a few of these guys, here, and then we get these three jets on each side. No idea what that could be. So at this stage, we are just, working on that and trying to put something. Stas is scrambling, and he can't put any sort of modeling into how to create these triple jets, coming at the same time. So we'll see how that's going to go. Then we have a mouse as well. Well, I can't call it mouse, as you can see, I can't call it rat, but this is a well-known, a beautiful bent tail galaxy, radio galaxies. So the galaxies right here, there, and there are bent tails. Most likely some galactic winds are blowing from the bottom up. But there is a mystery here. Somewhere here, right at the top there, or at this picture here, there is another galaxy. So that galaxy is very nicely connected with this tail. Now, that could be a chance coincidence? Of course, yes, it is. But until then, I'm going to call that conspiracy there as well. The next one is, I love this one, the killer AGN. Guys, this is not definitely the place to go. My master, Zach, student is working on this. This is beautiful. So have a look on the right-hand side, or your left-hand side, my left-hand side, what I'm doing now wrong, I don't know. Oops, go back. Okay, so this is an optical galaxy, Edge-on galaxy. There are two of these galaxies. Have a look, it's on the same scale. These are the radio images. So what we see the jets, and it's most likely that the jet from this NGC 5078 is hitting the jet here. Well, that's not a place to be. So the whole idea here is, well, these are the dangers. So it's quite a lot of dangers in the universe, and you don't want an M31 to shoot the jets towards you. That's the main point. So we're going to do a bit of modeling there, but this is one of the beautiful examples. Another one, which is we are totally puzzled, more circles. So on your left-hand side, what you're going to see is an ASCAP image of the face-on galaxy. What's the name? Caracondrula, that's the name of the galaxy. Nevertheless, this is a known supernova there. It's a beautiful spiral. There is a bar there, classical galaxy there. But as you can see here in the radio image, there is no central source there. We found about half a dozen of these sources, which is, absolutely phenomenal and fantastic. And we have no idea. One of the possible ideas is something called the Lindblad resonance. And probably I would need the whole conference to explain what it means. So please Google it, you won't understand there. Anyway, this is one of the possibilities why we see these radio rings around there. Of course, no one likes my naming this type of object, radio ring galaxies, RARIGs. Currently, people telling me that it's terrible to name the source. Araish, this is our PhD student, Hina. She's a real inspiration as well. Mother of three, She's a chief computer officer for a Woolworths and doing a PhD with us. This is her discovery, face-on galaxy. What's the number of this galaxy? 5938. She called it Raish, means adornment in Urdu. She's a Pakistani. Nevertheless, one of the things that she notices looking into this particular galaxy is when she looked in the optical image, she found that there is something here which does not, belong to there. So after a bit of a looking with this, we found this must be a jets coming from this face-on spiral galaxy. But then the problem became that we see the X-rays, which is not matching the radio. And then this is probably a third or maybe a fourth case of a galaxy like a Circinus A, where we are seeing a very powerful radio jets punching through the thermal X-ray. And it's, again, fantastic. You can see the multicolor picture here as well. All right, okay, more of these guys. The strange case of the LNC Orc. We found a beautiful Orc, which we think it's most likely to be a supernova remnant, the Milky Way. This is the two Magellanic Clouds, a small and large cloud. The object there, this is, the circle, which I'm going to show you in the next slide. So right there in our ASCAP, early ASCAP images, we found this beautiful circle, which we immediately called an Orc. So it's quite far away from the LNC, and it's basically all your mainstream objects of the LNCs here. So we follow up that with the ATCA, and we concluded it's most likely will be something that, it's some runaway supernova remnant from a runaway star. And this is, our investigations, but have a look. That's that object with a meerkat. Absolutely stunning and beautiful. So now we are very sure it's a beautiful circle. It's a typical SNR, and we call it intergalactic SNR. It's most likely about 1/3 away between us and the Large Magellanic Cloud. All right, okay, let me show you more of these beautiful things. Another one is the stingrays. Master Smeaton found these two guys. Now, these are the Large and Small Magellanic Cloud, and there is a huge tail here, tail of gas here, which is, I think, the biggest object in the sky, called the Magellanic Stream. Now, Magellanic Stream is just a gas. There are no stars there. So then we found a couple of fuzzy objects, which we call the stingrays. And originally, we thought these stingrays could be supernova remnants, like the one which I just showed you in the previous image. It's very unlikely. It's far more likely this is some type of an Orcs with the strange jets in this direction and that direction. We have more of these, of course, but just before I show you more of these, let me show you a beautiful ASCAP and meerkat and the optical picture of the Small Magellanic Cloud. All these red stuff are non-thermal type of objects. They're absolutely, fantastic and beautiful. This is the more of these objects in the zooming in. They're all SNRs. It's just beautiful. This is the Large Magellanic Cloud. Again, this is something which is an absolute treasure. It's beautiful, to have these objects, and we can study their evolution, particularly supernova remnants, H2 regions, planetary nebulas, and more. This is the bunch of the children of the revolution type of a next generation of a low surface brightened supernova remnants in the Large Magellanic Cloud. And this is a technique which I very briefly would like to show you. This is the ASCAP image. Excuse me. This is a optical image, and when you combine the two images, you can see very clearly this red stuff, which is SNR, a brand new SNR. Interesting new techniques that we are developing. Now that brings me to a pure Hollywood discovery from about a few weeks ago, which we call the teleos. Teleos means perfect. So just have a look, this top picture. This is a ASCAP picture. This is the galactic plane here. And then just below the galactic plane, we see this perfect object, which is that. We looked into H alpha as well. So basically we can't see that. It's exclusively seen in the radio, but have a look zooming up. So one of the first things that I asked the question is that could be a Dyson sphere. Of course, it's not a Dyson sphere. You expect a Dyson sphere to be seen in infrared. This is exclusively seen in the radio images. So it's most likely some sort of an SNR, but it's very difficult to understand why so precise. So you are the first group of the guys that I'm going to show the next picture. This is the meerkat picture of this object, much more sharper. As you can see, it's absolutely beautiful. Still a mystery to us, what's that there. But as you can see, it's a very sharp and it's absolutely beautiful. That means it must be expanding in some low density homogeneous environment. most likely some sort of SNR, most likely type 1a, but we'll see when the polarization. Now, I said exclusively over the last couple of days, we got a confirmation that it's being seen with a HESS. So we are quite keen on that. There are a few other objects in the field as well, which are super exciting. Some object called the MAVCA, which is a well-known, a high-energy object, supernova remnant in that space. Now, let me make sure that you understand, guys, that this is not a Jurassic Park, but it's a very important object that we found, and there is a little bit of interest here. Diprotodon is the giant wombat. And it's the largest of all animals that it's ever lived in this continent. It's extinct about 45,000 years ago. And we named this object as a Diprotodon. So the green circle that you see here, we knew about this object, but what we know before it's that. Now with ASCAP, we can see, how beautiful and fantastic it is. This is one of the biggest, if not the biggest, SNRs in our galaxy. This is the size of the moon. It's one of the biggest objects in the sky, especially in the radio sky. But it's not just that. We see that with the HESS, with the gamma rays in the Fermi, so which I think it's also super exciting and tells us a lot about the evolution of these objects and why they're important. Another one, which I have no idea why this is now on upside down. It's called Ancora. So let me not bore you too much about Ancora. What is very interesting is that Ancora was literally 7 days after we found this in our ASCAP radio images found by amateurs in South Africa. And not just, the Ancora that has been found by amateurs. We also have a discovery of probably the youngest of all, called the Perun in our galaxy, which is super exciting. We think it will be probably between 70 and 500 years old. Composite SNR, meaning that somewhere there in the center is most likely a pulsar. This is a pulsar wind nebula. As you can see, it's a very much circular shape. We do have a Raspberry as well, another interesting object where in the center we see some Stokes V parameter polarization, meaning that it's most likely that there is some sort of a neutron star or a pulsar there. Mast-Smeaton discovered the unicycle, as you can see, another potential supernova remnants in our galaxy. It's just to show you the power of the ASCAP, which is absolutely fantastic. We did a lot of stuff. This one is the biggest one. We just published this one called the Veliki, the biggest of all. Unfortunately, not in our galaxy, or fortunately in our galaxy, but it's in the LMC. It's about 45,000 years old. It's huge, it's big, it's bigger than anything. But it's not just that it's big, it's actually very bright as well, which is actually really puzzling us how to explain that. Nevertheless, there is more of these. This is the guy called the goat's eye. Now, I don't know how many of you knew that the iris of the goat is actually rectangular. So we think, this object is really goat's eye. Again, pulsar wind nebula in the center, which is wobbling, across. And let me show you a nice picture there. So this bit here is actually probably most likely how the pulsar is moving through the ISM, through the SNR, and this is, in a different frequency. So it's quite stunning from any perspective. We have Abeona as well, discovered Chris, one of our colleagues from Europe, discovered that, and I think should be published very soon. It's a quite cool SNR in high galactic latitudes. As you can see, all of these things are mixed mainly in the galactic plane. This is a Potteru, a beautiful story of one of my PhD students, Sanya, discovered this object in a galactic plane. The problem with this object is we know it's a pulsar wind nebula, so it's a pulsar is somewhere here at the top. It's moving, quite fast. The problem is, where is the SNR? So the SNR should be somewhere there. We don't know. That's an SNR, but it's too far away. That's an SNR, so it doesn't look, it's there. So basically, it's a parentless pulsar wind nebula, about 10 kiloparsecs away from us. So quite cool story, which we're going to follow up in the future observations. This one is just over the last few days. It's really puzzling us. Another supernova remnant. Yes, I know, another supernova remnant. But the problem is, right in the center, we do have something which is a low mass X-ray binary. So low mass X-ray binary means it's an old object. It means a few million years old. and the SNR can be only a few tens of thousands of years old, so it doesn't work. One of the possible ideas is that we have something called a very special case not seen before, which is underluminous supernova explosion. All the supernova go something like 10 to the 48, 10 to the 52 ergs explosion. It's most likely, it's possible that this explosion here is underluminous. In that case, this will be only 50 years old. I'm brave enough to say 50 years old, and it's only about 200 parsecs away from us, which is absolutely amazing. We didn't see this with the naked eye, which is a big problem. We don't know why. So it's a baby spider called the spiderling, because we think it's quite possible this is a part of the evolution of this central object there. We do have a Statue of the Liberty. That's not my fault naming this object Statue of the Liberty. We need to see how we're going to do this. It's a beautiful, cool runnings. The problem is, again, we have a pulsar V nebula somewhere there. We're not sure if it's associated with this emission up there, but it's a huge, big, but it's also seen in the gamma rays. More of these are left, right, and center. Again, I'll give you just a very quick example of to be a pulsar V nebula or not. On the right-hand side is the one which is definitely pulsar V nebula, and on the left-hand side is not. How I know? Multi-frequency. You look, the optical, you look at other images. They look similar in the radio, but it's completely different. Master Bradley, sitting also here, found something which we did not expect when we built the ASCAP, a reflection nebula. Reflection nebulas, diffuse gas and the dust clouds illuminated by the young stars. This one is the Master Bradley called it Lagotis. He can tell you, you can ask him later on the questions why. On your left-hand side is, I think, optical image, is it? Yes, optical infrared composite image. The right-hand side is an ASCAP image. And it's not the only one that he found that. No, that's the same one. It's just, in a nicer color. I think I like these colors a little bit more. Nevertheless, he found a few others in Canis Major R1. Another area where the ASCAP is going to dominate in the future will be this area here. I'm doing terrible with the time showing you all these things. A beautiful infinity planetary nebula, Albany, also sitting here, is found. This object on the left-hand side, you see the beautiful HST image, and the ASCAP image. It's a purely thermal emission there. And this is another new mystery that we call the Phoenix at this stage. We have the youngest planetary nebula right in the center, well studied, heavily observed by ALMA, ATCA, whatever, but they did not have enough big field. As you can see, there is a circle around there, which we are very sure, very positive, it's a non-thermal, so we can't explain where this is coming from at all. More work needs to be done there. This is really preoccupying my brain over the last few days. Nice picture here. Again, you can see a beautiful ellipse here with a central part where is this youngest of all galactic planetary nebulas. The phone number is that, well known. More of these are associated, more of the ASCAP discoveries are with a Wolf-Rayet star. This one is a 16, so we have a star which is Wolf-Rayet, very massive star, a runaway star moving in that direction, and it's basically creating these emission. The previous part of the puffing of Wolf-Rayet star is that one there. So, quite exciting. Again, something that we haven't seen before. This one is WR40. Again, quite nice object there as well. Kyklos is one of my favorite. We found this in one of the ASCAP images, and as you can see in the red is the optical image. There is a star, very bright star. I think it was a 6th, 7th magnitude, but it's not right in the center. So after a lot of investigations, meerkat observations, we thought that we think that star have nothing to do with this ring. It's probably something else, some other Wolf-Rayet star. Still puzzling us. Yeah, sorry, I have to go back and tell you this is a beautiful wine, Kyklos. The name of object is a Kyklos. Kyklos means a circle in Greek. So a beautiful wine. If you get a chance, guys, you won't miss it. This one is again strange ISM in the LMC filament, quite big one. We have no idea why. One of the ASCAP images at the top. It's beautiful. It's a classical Dr. Strangelove. When you are really scrambling yourself, and saying, well, I have no idea why and what's going on. I have to show you this one. Let me see if I can play this movie. This is a Miller 1 and Miller 2. This is a beautiful discovery of radio flares from a nearby binary M-dwarf star. Let me see if we can play this. You want to see that? Have a look. This is a 5 hours observations, 5 hours ASCAP observations. You can see two stars, M-dwarf stars. The distance is 17.5 parsecs away from us. And from one star to another star is like from one end of the solar system to another end of the solar system. This is, I think, third or fourth system found. The most famous one is the UV SETI. It's safe, guys. You know, it's not gonna kill us or anything to do. But I think, you know, it's quite cute. This is the power of the Blues Brothers, you know, that you can find and ask. It's quite cool. I was talking a lot about the multi-messenger astronomy. Let me show you, you know, some of the results from other bands, not just the radio bands. What is very popular these days? This is the future of astronomy, EELT, CTA. You've heard a lot of talks today about the CTA and the SKA. What you haven't heard is the KM3 I'm going to show you some phenomenal new results and coming from the KM3 which is a cubic kilometer network. But you've heard that LSST is, you know, coming quite big time to us. The James Webb Telescope is also there. Rosetta, you know, is still there, even that it's not operational for the last couple of years due to some political problems. Nevertheless, we have a great future. So let me talk about the KM3 cubic kilometer neutrino telescope. I'll show you a bit more of where it is, but it's actually it's built for exploration of the neutrino universe, study the fundamental properties of neutrino, and actually, you know, even sea life, because it's in the Mediterranean waters, and I'll show you a bit more of these results there as well. So neutrinos are fundamental, lightweight, elusive, abundant, diverse, oscillating, mysterious, and very mysterious as well. Now, this is a movie shows you where the infrastructure of the KM3 the one Orca and Arca. The Orca is just south of the France, and the one which I'm going to focus more is Arca here, south of the Sicily. And as you can see, you know, in this movie, their size. I'll show you some more details of that. And it was recently a really big discovery of the ultra-high energy neutrino. So I don't know what's here, why the black screen, but we'll see why the black screen. Yes.
Is the stage for mysterious
I'll just
and
go
violent
very
phenomena.
quickly. This is a promotion video for 2 minutes, and I don't have a time to spend the 2 minutes on all this. It's basically showing the discovery, which is a discovery of ultra-high energy neutrino. Not seen anything before, and I'll show you what it means and how that is important for the future of physics. The good news is we are asked to put a presentation in a number of European funding government organizations, so they are really keen to see how this is going to work in the future. So we discover 220 pevatrons neutrino, a muon there when we published this in February 13th, 2025, 2 years after the event happened. And the event was catched, and I'll show you in one of these telescopes there. So the area is about 1.5 degrees, and once when this neutrino was announced, we looked within the ASCAP. This is the area where it could come, and we selected these three sources as a potential counterparts where this neutrino could come. And the interesting thing is we looked into these three sources. This is Phaedra, the Greek Creation princess in Greek mythology. We think, you know, it's something quite possible that this Aegean galaxy with quite a lot of exciting X-ray and radio sources, there could be an origin. Another one which have a very strange radio polarization, which we call the Hebe, and I really like this one as well. It's a second option. The third option is actually the Blazer, and quite confidently I can tell you that this Blazer is now running a candidate for the origin of this ultra-high energy neutrino. So this is the telescope. One of the possible problems that we have at the moment, so quite a lot of papers written, is tension with the ice cube. In a way, one should expect the ice cube, which is in the South Pole, should see all this, but it didn't see. So not to bore you any further, I just want to, fly through the next 9 minutes of my talk in the 120 slides to tell you that it's everything about the energy. It's all the stories about the energy, to remind you that we are sitting right here. There is a dot up there. That's where we are sitting. I just want to remind you that the whole this is about the origin of life, that we all search for a water. As you can see, I showed you, I'm far more interested in cosmic rays. I find the cosmic rays. I know that there is no life there. Unfortunately, guys, there is a far more cosmic rays real estate than the real estate we can find the water. By the way, if you find the water, you only have a 50% chance to find the life, at least. That's what they're telling us with the statistics. There is a water on Mars, of course, but this is the way how we think that the life started at the planet. I love this slide just to ask myself why we're doing what we are doing. And there are definitely two possibilities, and I'm sure that all of you would like to ask me, what is the story with aliens? And maybe we are alone, maybe we are not alone. Both of these things are absolutely amazing. So if we are not alone, where are they, guys? I don't know. So I think actually I know. I think, the universe is empty of life, and this will be a very strange. I really think that all aliens are sleeping. So let me explain this before I go to the next slides. And I'm going to explain this, and I'll probably, stop there, because the part 2 of my talk will take another 3 hours of talking. So what I have on my left hand here is a mobile phone, okay? The mobile phone, this is an iPhone 11, I think. It's terrible, right? I'm not keeping up with the latest generation of the mobile phones. So I think the latest generation is what, iPhone 16 or whatever. That tells you that over the past 16 years, we had each year a new iPhone, new mobile phone, which is better than another one. That tells us that we are very thirsty for a technology. We are very thirsty for the next generations of computers. That tells me that in the years to come, the computers that we are using for ASCII data reduction are not going to be fast enough, big enough. That means it's going to cost us energy. Don't worry about the money. Now, energy means we need to invest energy. We need to create the energy. And not just to create the energy, we need to create the energy to cool down our computers, right? So it's okay with my mobile phone at the moment. But the future mobile phones needs, the cold, the big computers need the cold weather. So effectively, we have a problem in the years to come. We need a cold weather. What we're going to do is, well, fridges now works, right? Okay, cool rooms are working. But in 500 years from now, how are we going to manage all that? The message here is that at some point, we need to move our computers upstairs, outside of the planet Earth, outside of the solar system, outside of our galaxy. So to put you in perspective, guys, I really think that all aliens are sleeping. They figure it out. They know that they need the computers, and they are all sleeping. Why? Because they need really a cold weather. And at the moment, the universe is too hot, 2.73 kelvins. So I really think they're all sleeping. It's crazy. So I did a lot of calculations. I think there is quite a lot of assumptions that I'm doing here. I'm not going to bore you too much about that with the civilizations and a lot of assumptions there. Yeah, you can argue with me all day about that. But effectively, I think all these advanced civilizations who depend on computer power they figure out, well, this is not a universe that I need for. In other words, I looked, where we should wake up. They should wake up, right? And we did some calculations. Believe it or not, we do have a number. Right? The number is about 1,400 billion years from now, give it or take, or when our universe is reached this temperature. So that's where the aliens are. All the kids, whenever I go to school, ask me this question. So I love to tell them that they're all sleeping. It's a lot of problems here, of course, but I think it's a cool idea. Another cool idea that I could run through here and tell you about the major extinction events. We looked into our galaxy. We moved the Earth around over the past 500 million years. And what we found, anytime we cross the spiral arms, we have a problem, major Earth extinction. So interesting thing is that anytime after the major Earth extinction, what is happening is basically a more life goes up, which is actually like a fertilization. So it's a good for us. The bad news is it's in the next 1 or 2 million years, we're going to enter into a spiral arm. So the things are not doing good from that perspective, perhaps. So massive Earth extinction says like fertilizers, cataclysm is engine for evolution. It's a good for us, actually. Yes, it's going to kill us, but you know, if the big animals didn't die 66 million years ago, we wouldn't be here. I think, you know, that's one of the conclusions there. Yes, we need a diversity. Diversity is essential, you know, for all this. So without errors in diversity, there is no future. So we have 2 options. I know everyone would like to say that Earths are common, but I think, you know, we should really consider that Earth is very rare. I don't have much time. You know the Drake equations. There is a rare Earth equation as well, which is, you know, showing a lot of different things. And one of them is that actually we have quite a lot of other problems, including the volcanoes. So my argument is that Earth is special and unique, and that maybe it should be called the Galactic National Park, I think. So a lot of things could happen in the future. Once again, I really think that supervolcanoes are the one which could cause most of the problem. Ice ages, you know, inconvenience, comet asteroids, nearby supernova explosions. Yeah, if it's too close, you know, we could have problems. One of the things that I'm sure that we can learn as a main lesson is that there are no miracles in the past, as I said at the very beginning, and I don't expect to see them in the future. So I think, you know, we have a very clear future as far as astronomy is concerned. The second part of my talk, which I don't have a time, would be very much about the politics and tell you all the problems associated with the politics and the things that we are talking, but we are not talking, the way how we are killing each other with you know, in all possible ways. But let me just, before I finish, let me tell you what is all this number means. Right, okay, put this on 1 million years. This is the amount of annual growth in a total growth for the next million years, if you want to double up. In other words, Miroslav's iPhone 16, sorry, it's 11, but let's say 16, in the next million years, it will be an iPhone 32 only. This is the growth that you need, 0.0007%. The bad news, guys, is at the moment we are doing about 3%. This is the number. This is the way how in the next million years the planet would look like. And I'm really not optimist from that perspective. It's a lot of stories that I would say about who says what, the way how we are killing a planet with the plastics, with everything, the growth, annual growth rate. We think, you know, that there is a huge misconceptions about things such as perpetuum mobile. You know, we're going to invent the things, which is fantastic. Yes, by now you are figuring out that I am very much into this idea that equity. These guys won the Nobel Prize telling us basically that this dematerialization zone is impossible, that we have a problem in any industry that wherever we go, in other words, we cannot create perpetuum mobile. Whatever machine that we create, it's not going to save us. It's just going to put them more problems. A lithium as well. We dig the lithium, we send to China, and then we bring the cars from China here and the batteries. It's a footprint. It's absolutely terrible. A lot of misconceptions. You know, in our environmental problems that we have at the moment, in the way how we are solving, avoiding solutions or adapting solutions. And as I said, by now you understand, you know, where I'm coming from. I really would like to see a properly distributed wealth. So there is no global discussion about the politics because no one cares about the people. There's plenty of models that you can find in the literature, but no one is talking about the people. So they don't like us. Also, these guys got a Nobel Prize, and I really love this. What they said is there is a small group of elite. I really, you know, I'm going to stop. I promise I'm going to stop here. There is a small group of elite, you know, who will, in a case of emergency, if the comet hits the Earth, they will live probably 2 weeks longer than you and me. So what's the point? It's basically, you know, the whole system is wrong. You know, it's not built for the future. So I could tell you about the ethics. I could tell you, you know, about the morale and the way how ethics and morale grows. Oh yes, I love this one. Sorry, oops. I want to show you this one. This is Abraham Lincoln. When I do good, I feel good. When I do bad, I feel bad. That's my religion. I really like that. This is, you know, absolutely fantastic. So yes, you know, we can talk about the future. We know that there is a far more future than there is a past as far as the humans are concerned. So how are we going to deal with this? What we're going to do about that is I asked my students if in 1,000 years from now, they find out that it's our fault, that we are the one who started all the problems there. What should we do? Shall we do something? Is this good or bad? 95% of my students said, yes, it's terrible. We should do something about it. 2% said, yeah, it's good. Let's kill the future. Who cares? And the 3% say, I don't care. Which tells me, that effectively we are actually, we really, care about the future. Not as much as, we should, probably. So low entropy is actually the ultimate human value. And a lot of people ask me, do we need a new religion? No, not more religion. So my conclusion here is, and at that point I'll say is, we have a lot of things to do. The humans are very cool and interesting. I really think that these are the golden days for astronomy. What's going to happen in the next 10, 50, 500, 5,000 years? I don't know, of course. What I can tell you is that we are all different. We all should accept that differences, like, all the objects that we see in the universe, it's absolutely fantastic. We have to look, in every single direction, not just in one direction. And guys, please, don't hesitate to ask me any question. Thanks very much.
Miroslav, very entertaining. Lots of ideas to.
Please enjoy the story. Cool.
Do we have any questions?
Right.
As well, thanks. Okay, I've got a couple of questions, Miroslav. Tell me, please, what a cosmic day is. 38.7 million years? I was struggling to work out what that interval is.
13.77 billion years is 1 year. And then divided by 365 and you'll get a 1 day.
Okay. All right, I understand. So you divide the age of the universe by 365 and you get a day. I like that. My other question, a little bit more technical perhaps, was why was I was talking about your object Helios, which is just the most beautiful thing in the sky, I think, at the moment. Why is the Meerkat image so much better resolution than the ASCAP image?
It's just the setup of the Meerkat telescopes are such that their baselines are a bit longer. It's a more telescopes than ASCAP, so it's a little bit different purpose. It's a similar frequency range, so they are just a little bit sharper because their resolution is slightly better. To put you in comparison, ASCAP is what, about 12, 14 arc seconds resolution, and the Meerkat is about 8. Pleasure.
We have time for a few questions. Bruce.
Bruce.
So many questions I could ask, of course, but actually one technical question about the Magellanic Stream. You said there were no stars in the Magellanic Stream. I mean, why not? I mean, isn't it the stream caused by the motion of the Magellanic?
I think this is one of the top. I think why the question is why no stars in Magellanic Rim. Yes, it's in Magellanic Stream. It's $1 million question. Apparently, they've seen at the far end in the northern hemisphere as some possible stars. I've read that, but irrespective to that, it is a quite big mystery. It's been around for 60, 70 years. A huge amount of Sir Jos Blunt-Hawthorne, I think, spent all his career searching for stars in a Magellanic Stream, and there is no sign of that. We found stars in Magellanic Bridge, which is connections between the small and the large cloud, but not in a stream. It's probably due to I don't know, ram pressure stripping last passage around it's sort of a bleeding of the gas in last passage around the Milky Way, most likely.
Okay, thank you.
More questions, especially about life and the future of civilization. Yeah, yep, up the back there.
Thank you, and thank you very much for the talk. Just wondering, you showed us at the start a lot of very pretty, but very diverse objects that you and your group are working on searching, investigating. How did you go about finding these objects? Like, to me, they're they're so diverse that probably one search isn't going to find all of them. Are they sort of following up on known anomalies that are out there?
Right. Okay. I love your question. The question, the answer to that question is a years of experience working in this field, reading the papers, getting interested in all these sources, trying to recognize when you see them. And it's a beauty of the ASCAP, you know, that every week we get a 64 square degrees field, which I download immediately and have a look, what do I see there? You just, look into all that, you try to see, is there anything interesting, what's the interesting, what's the, different, investigate and look into all this. And then you acquire all this experience and knowledge. And a couple of years later, you end up with all these objects, which are all different. But the point of all these objects, they are an extraordinary objects, which we don't have an answers at the moment. There is a plenty of objects, other objects which are well known. So I've really tried my best to show you the ones which we don't know what they are really.
Yeah, it's very cool. Thank you.
Pleasure.
Gary at the back.
You're younger.
Just wondering if you could elaborate a bit more on the aliens are asleep argument.
Mm-hmm.
So, as I understood it, 3 Kelvin universe is too warm right now to keep all their computers cold, but so they have to wait.
Yeah.
Can you elaborate a little bit more on that
can.
argument?
We actually written a paper. We managed to publish that paper. You can imagine, how many referees didn't like the idea that the universe is way too hot for computers that you would need to understand the universe. So the idea is that at some point of the technology that we can predict, the physics can work only when it's a super cold. And this is as cold as the physics, that's what the physicists are telling me, is as cold as you can go in a given universe, the number which I showed somewhere before. So the universe at the moment is 2.7 something degrees Kelvin. They're telling me is that the computers that they can imagine, that is way too hot, that basically you will not cool enough the computers and particles at that temperature. So you really need something much cooler. I do agree, guys. There is quite a lot of problems, here. How you're gonna wake them up and so on. How you're gonna hibernate all that time. But the whole idea here is that we are that we have problems with the computing, philosophy. We heavily depend over the past 70 years on a technology which requires energy in various forms. And you may remember one slide that I put that the whole universe is about the energy. It all comes down to energy. And of course, the different models of the universe, are we gonna expand forever, big crunch or whatever, but the temperature at the moment is way too hot.
Okay.
Come on, guys, it's a cool idea.
I
It's a cool idea.
have a question
Yes.
again about the future of life.
Uh-huh.
Why alien civilizations aren't or not there. And Carl Sagan mentioned that any sufficiently more intelligent life would see us as a little ant on the ground. And why would they be even concerned about us? Because in 100 years' time or 1,000 years' time, we'll have telescopes that could image individual cities on planets that are thousands of light years away with super wide interferometric systems. If you extrapolate what we can do now, and assuming that we can put resources into these things, I'm wondering whether they would see us and we're so far behind them that they would learn nothing from us.
Yeah.
So therefore, they would just, okay, great, let's continue what we do and ignore what we do.
I agree. It's a possibility. It's a very distinctive possibility, and everyone argues along those lines that they are hiding from us, or sorry, using a way too strong word, that they are hiding. They're just monitoring us. My argument is different. I don't want that to happen. I wouldn't do that to them. It's just from my perspective, I would really like to know that they exist. Unfortunately, I think I showed you a lot of arguments that it's not that obvious, at least, from this perspective, that aliens exist. And I'm a bit of a joking with his computing and hot universe at the moment, but it is quite possible, anything. The Hollywood covered everything. Someone told me whatever, we're going to find about the aliens in the future, Hollywood already covered that. So this is a, distinctive possibility. Agree.
We have a question down here.
Yes.
You could just wait for the microphone.
Microphone.
Yep, thanks.
When Earth's oceans dry up, will there be a huge blanket of plastic left?
Oh, plastics. Yeah, I had for a 0.1 second that slide about the plastics. Plastics is well known as one of the biggest problems that we have at the moment. My point about the plastics is that a lot of people believe is that we will gonna easily invent a machine which will solve that problem. And that's not true. Amount of energy, time, money, call it anything that we're going to invest in that machine, it will be counterproductive. It's not going to solve the problem at all. So not just the plastic, almost everything, lithium, the way how we are actually killing with these resources, how we are not properly using the resources that we have at this planet is quite dangerous, and it's a long term. My point, at least I tried to send the message about how much we care about the future generations. Most of us here sitting in this room, we know our grandparents, we know our parents, us, our kids, and our grandkids. 5 generations. 5 generations? That's what, about 120 years? Yeah, roughly. Is that enough? Probably not. Again, I would really like to send a message that we need, as soon as possible, a general discussion among absolutely every single government, and I know it's utopia, about what's the future of the planet. I don't like to see the problems. We don't have enough diversities. It's everything is up for a sale, for a profit. I think I showed you this question about 3% per year profit. If you're going to have a 3% per year profit, you're going to kill yourself 100 years from now. Just not sustainable. Absolutely not sustainable. If you look, the Wall Street, it's just wrong. It's a fundamentally wrong. So I don't think that we have a problem in astronomy in terms I really think we can divert the comet or asteroid if we can catch this early enough. Yeah, I said volcanoes may be a problem, but I think we have a far more problem inside of us, the way how we are governing the planet and the way how we are looking into a planet. So for a public, astronomy is doing well, fantastic. Astronomy is telling you is we have a safe future, at least for another 100 million years, 50 million years, whatever. But we need to take care about what we are responsible for.
Okay, thank you for the presentation tonight. It was very interesting, very wide-ranging. My question is regarding the new telescopes that are coming online. So the Square Kilometre Array telescope and the new Vera Rubin Observatory in Chile in the optical realm. Is that having an impact in your work?
Yes, absolutely. It's I don't know which one I'm going to pick up. I'm not going to pick up SKA. I'm a radio astronomer. I should pick up SKA. Why? Oh, that's going to put me in political troubles. So I'm really looking into LSST, to work with LSST. This is a phenomenal opportunity for all astronomers in the next 5 years at least. SKA is about 2 years away from now, the best case scenario, let's say 18 months, something like that. So SKA will also put the new discoveries, but I think Vera Rubin will be a breakthrough in a number of fields in astronomy, particularly, I believe, in a field of planetary solar system astronomy, where even the first results from the first image show up. I don't know how many new asteroids, which is fantastic. It's great. So yes, but it's not just Vera Rubin and James Webb or SKA. There are a number of other telescopes, and I probably should spend more time talking about the CTA and the eRosita as well, the X-ray, the next high energy generations of telescopes. They're gonna, I really think they're gonna make a huge difference to us. How quickly is all that? Is this, quickly enough? Yeah, as a scientist, I would love this to be quicker than what it is, but a lot of money. This is not a simple. Yeah, I didn't talk at all about the gravitational waves. I apologize. Paul Lasky is not around. Good. So, the gravitational waves is also, a very important part of the puzzle. I think, we are well covered with the neutrino. Yes. Yeah. IceCube and the KM3 net will make a number of good discoveries over the next 10 years. So
Okay.
I think we are safe.
Okay. And gamma rays?
Gamma rays, as I said, CTA is the future. Is there anything else apart of the CTA around? We're not going to talk about it. Yeah. So Chinese are doing something, are they? Yes.
A few other additional new gamma ray telescopes being planned around the world.
Okay.
CTA is the best. Full
Great.
stop.
Thank you so much.
Pleasure.
Okay, well, I think we might have to wrap that up. So we might just thank Miroslav once more.
Thank you.
And then we have a little gift for you with a little message.
Oh, we're going to drink that tonight, right? Okay, good. Thank you. Thanks very much.
Thank you.
Yeah, beautiful.
And thanks everybody for coming. I think we have the YouTube being recorded as well. We can archive that. So if you want to go back, have a look. So let's thank Miroslav again. Thank you for coming.
Thank you. Thanks.